Okay, let's do lesson 10.8, equations of circles, page 575 in your book. Let's start it off by looking at the distance formula. If you remember the distance formula, x of my second point minus x of my first point, that quantity squared, plus y of the second point minus y of the first point, that quantity squared. The whole thing take the square root of, and that tells me the distance between point 1 and point 2. Now let's take a look at the concept of a circle. In a circle we have a center point, no matter where it is, a center point, and we have a radius, and all the points on the circle are the same distance away from that center point, the radius. So if you were actually to take a center point, let's say 3, 2, use it as your x1 and y1 values, and plug it into the distance formula, you would get something that looks like this. So in this example, r is 4, so our distance is 4, is equal to, well, the x2 value stays the same. That would represent any point on the circle. But x1 is my center point. So 3 and 2 are the minuses. x2 minus 3 squared, y2 minus 2 squared inside the square root sign. Now I get rid of the square root sign by squaring both sides of that equation. 4 squared is 16, and the square of this side just gets rid of the square root sign. And so then I end up with this equation. Now let's say I use the standard letters h and k as my x and y values for the center point of a circle. Okay, and don't worry about why I use h and k, just remember that h and k are the center point of a circle in the standard equation. And if I do that, and I plug it into this equation up here using h and k rather than 3 and 2, I change this equation over into x minus h, quantity squared. Remember, h is my x value of my center point, plus y minus k, and k is my center point's y value, squared is equal to r squared. And this is your standard equation of a circle. But you can see where it came from. It came from using the distance formula and recognizing the fact that the distance is always the same from the center point to any point on a circle. Okay, let's use that in a problem. Let's say we're asked to figure out the equation of a circle given a diameter of 4 and a center point of negative 2, 4. Well, the first thing we do is to say, since we know it's a diameter of 4, we know the radius is half that, or 2. So then, all we have to do is plug the radius 2 and our 2 values for our center point into our standard equation. So we get x minus a minus 2 squared plus y minus 4 squared equals our value, which is 2 squared. And then you simplify that or fix up the issues there. A minus becomes a plus. So x plus 2 squared plus y minus 4 squared, and 2 squared becomes 4 at the end. And this is the standard equation for a circle of diameter 4 at center point negative 2, 4. Let's try that again with another example. This time it's pretty simple. R equals 3, and our center point is the origin. So since our center point is the origin, when we write out our standard HK formula, it's x minus 0 plus y minus 0 equals my radius squared, 3 squared. And you simplify that down to x squared plus y squared equals 9. All right, now let's move on to example 2. In example 2, it's a little bit trickier of a problem, but it's the same concept. Find the equation of a circle where the diameter is 14, but this time they're not giving us the center point. They're saying, hey, this is a circle that's tangent to the following 2 lines, y equals negative 1 and x equals 4, and the circle itself is mostly in the 3rd quadrant. So I drew an example here of the 3rd quadrant down here. I drew a dotted line right here and labeled it y equals negative 1, and a dotted line down here and labeled it x equals 4. And then I said, well, now I've got to find the center point. I know that it's going to be over here somewhere because that's where my circle is mostly lies in the third quadrant. So I take my x value of 4, and I say, since my diameter is 14, my radius is 7. So I've got to move from this line that way 7 units. So 4 minus 7 equals negative 3. That tells me the x value of my center point is negative 3. So let's do the same thing with y. The top of my circle, the tangent line, is negative 1. So I got to move down 7. So minus 1 minus 7 is minus 8. So the y value of my center point is a minus 8. So there is my center point, negative 3, negative 8. And I kind of drew it right there and kind of half drew the circle there. All right, but the question is, get us the equation for that circle. So we've got to write the standard equation. So I say x minus my h value, x minus a negative 3 squared, plus y minus my k value, negative 8 squared, equals 7 squared, 7 being my radius. And I simplify that or clean that up, x plus 3 squared plus y plus 8 squared equals 49. And that's the equation of a circle with diameter 14 that lives mainly in quadrant 3 that is tangent to the line y equals negative 1 and x equals 4. The next example, they ask me to graph, and they give me the equation, and I'm supposed to graph it. So first of all, I look at this. Here's my equation, x plus 2 squared plus y minus 3 squared. Now, if you take a quick look at our original standard equation, x minus h and y minus k. So the values inside of my formula have a minus value, which means that that's the opposite value from what's in my equation that is given to me. So my x value is not 2, it's the opposite sign of that, which is negative 2. And my y value is not negative 3, it's the opposite value of that, which is positive 3. So I now have a center point of negative 2, positive 3, and I need to find out my radius. Well, this is r squared, so the square root of 16 is r, so that means square root of 16 is also 4, so r is equal to 4. So then to graph that, I drew a coordinate plane. I found a center point of negative 2, 3, and I put my center point out. I draw a circle and a radius of 4 on my circle. Not the best drawing in the world, but you get the drift. And finally, let's try this. They give me the following example, x squared plus y squared equals 9, and said graph it. Well, once again, I look at this, and my h and my k values are missing. There's no h and no k, which means there's 0. So my center point is at 0, 0. Well, what is my radius? Well, the square root of 9 is 3, so the radius is 3. So when I draw my coordinate plane, my center point is the origin, 0, 0, and my radius is 3, and there's my circle with a radius of 3. All right, finally, the last problem is a little bit trickier problem. They're going to give us 3 points and tell us that those 3 points are on a circle. What's the center point of that circle? Okay? Well, the first thing you have to figure out of what's the center point of that circle is how do I figure out what the center point is given 3 points? Well, first of all, here's my 3 points. A is 4, 4. B is negative 4, 6. Or B is 0, negative 12. And C is negative 4, 6. And you can see right here, this line right here represents my coordinate plane origin point. Right here is the origin. Okay? So now, how do I figure the center point? Well, if these 3 points are on a circle, okay, then I know that my center point is somewhere in this area over here. The first thing I need to do is realize that if this is on the circle and this is on the circle, the line between them, right here, that is a chord of the circle. And this point are on the circle, so that is a chord of the circle. And why did I pick those two? Because I knew that the center point is over this way. Okay? So, now that I've done that, I know I've got a chord and a chord. And if you go back into page 537 in your book, there is a theorem, 1013, that states that if you have a perpendicular bisector of a chord, that it goes through the center point of your circle. So bisecting this segment right here, I get this point right here. That happens to be point 2 minus 1, 2, 3, 4. 2 minus 4. Okay? I got that from doing the midpoint of 4, 4 and 0, 12. You can look up the midpoint formula if you want to. Then I take a perpendicular line off of that. Okay, and that is in the best drawing in the world. So now I know that my center point is somewhere along that perpendicular line, but I don't know how far out it is. So I need another perpendicular line, and I said, well, I get another midpoint from a second chord, and this midpoint ends up being 0, 1, 2, 3, 4, 5. Once again, figure that out from the midpoint formula. And what you do is then draw the perpendicular bisector on that. Once again, not the best in the world, but both of those are perpendicular bisectors. And where they cross is your center point of your circle. And they actually cross at, officially, if I had drawn it perfectly, negative 2, comma, negative 3. And so now I know the center of my circle, okay? I would have to know the radius of the circle to figure out the final equation for the circle. But once I know the center point, the rest of it is just using the distance formula and figuring it out. So there you go.